Welcome to the Explainer. Today, we're going to do something pretty cool. We're going to follow a single hello message on its incredible high-speed journey across the globe. We're going to see exactly how it gets from your screen to someone else's, all in the blink of an eye.
I mean, you've probably wondered about it, right? It feels like magic. You tap send, and poof, it's there. But it's not magic at all. It's actually this incredibly well-designed system of rules and a massive global infrastructure that we call a computer network.
So, to really get how this journey works, you first have to understand the map of this digital world. And that map? Well, it all begins with a pretty simple idea.
At its heart, that's all a network really is. It's just a bunch of stuff. Your phone, your computer, a massive server on the other side of the planet, even the printer in your office. All connected and, most importantly, all able to talk to each other.
And any device that can send, get, or pass along data is called a node. So think about it. Your phone is a node, the server you're trying to reach is a node, and every single piece of gear in between that helps that message on its way, yep, that's a node too.
Now, our little hello message actually travels through a few different types of networks, and each one is bigger than the last. It might start in your personal area network, or PAN. That's like Bluetooth connecting your phone to your earbuds. From there, it jumps onto your local area network, your LAN. That's basically your home Wi-Fi. And then it launches onto the big one, the wide area network, the WAN, which is the massive global system that connects pretty much all of us. And when you weave all of these different networks together, the personal ones, the local ones, the citywide and global ones, you get what's called the internetwork. Or, as you and I call it, the internet. It's really just a network of networks.
Okay, so in a system with literally billions of devices, how on earth does your one tiny message find its exact destination? Well, it relies on some really specialized hardware that acts like a GPS and a super efficient traffic control system all rolled into one. All right, let's meet these traffic cops. First, you've got the hub. It's not very smart. It's like a town crier just shouting the message to everyone in the square, hoping the right person hears it. A switch is much smarter. It's like a mail carrier who knows exactly which house to deliver a letter to. But the real genius here is the router. The router is what connects completely different networks, like your home Wi-Fi to the wider internet, and it's always figuring out the absolute fastest, best path for your message to take. Now, to make sure all of this works perfectly, it doesn't matter if you're on a brand new laptop or an old phone, the entire system follows a standardized set of rules. Think of it like a 7-layer instruction manual for data. It's called the OSI model. And the real beauty of the OSI model is how it takes this huge, complicated task of sending data and breaks it down into 7 smaller, much more manageable jobs. Each layer has one very specific thing to do, from dealing with the physical cables all the way up to the app you're looking at on your screen. And hey, if you want a fantastic way to remember these 7 layers, starting from the bottom, just remember this sentence. Please do not throw sausage pizza away. That's physical, data link, network, transport, session, presentation, and application. See? You'll never forget it now. Okay, let's really get into it. We're going to follow our hello message as it travels down through these 7 layers on the device that's sending it. This whole preparation process is called encapsulation. It's kind of like getting a package ready for international shipping, with each step adding a new label or instruction. So here we go, top down. At the top layers, 7, 6, and 5, your app creates the message, makes sure it's in a language the other end can understand, and opens a line of communication. Then at layer 4, the message gets chopped up into smaller pieces called segments. This is super important because if one little piece gets lost, you only have to resend that one piece, not the whole thing. Layer 3 adds the IP addresses. That's the global mailing address for the final destination, turning segments into packets. Then layer 2 adds the local hardware address, creating frames. And finally, at layer 1, it all gets converted into electrical signals, ones and zeros, or bits, ready to fly. And just like that, those bits travel across the world and get to where they're going. Now, the receiving device has to do the exact opposite. It's time to unwrap the package. This is called de-encapsulation. So the whole process just happens in reverse. The message travels up the stack. Layer 1 reads the electrical signals. Layer 2 strips off the frame and checks the local address. Layer 3 checks the packet and confirms the global IP address is correct. Then layer 4 is the magic step. It reassembles all those little segments back into the original message. Layers 5 and 6 manage the connection and translate the data back into something readable. And finally, at layer 7, bam! Hello pops up on the screen.
So, what's the most mind-blowing part of all this? That entire complex journey, packaging the message down through 7 layers, sending it across the planet through who knows how many routers and switches, and then unpacking it all the way back up through 7 more layers. All of that happens in less than a second. It is an absolutely extraordinary feat of engineering. So there you have it, from a simple hello to the most complex, world-changing technology. It all runs on this same fundamental rulebook. And now that you know the rules of the road, the only real question left is, what do you want to build with them?